Picture this: a machine that weighs 1.2 million pounds, stretches 133 feet from nose to tail, and can yank a 3,600-ton freight train up a mountain grade that would challenge a modern truck. Now imagine another that screams past at 100 miles per hour in 1934, when most cars couldn't hit 60. And finally, consider one that grips the rails with 560,000 pounds of crushing weight, moving 14,000 tons of iron ore in a single, thunderous journey across Minnesota's frozen landscape. This isn't fiction. These are the Big Boy, Flying Scotsman, and Yellowstone, three locomotives that represent the absolute pinnacle of steam engineering. But here's the thing that makes engineers argue late into the night. They were built to solve completely different problems, which makes answering the question, what's the best train ever built, a lot more complicated than you'd think. Three kings, one crown. When Union Pacific needed to move wartime freight over Wyoming's brutal Wasatch Mountains in 1941, they didn't ask for the fastest locomotive. They asked for one that could do the work of three engines. The result was the Big Boy, a 4884 articulated monster that could exert 135,375 pounds of tractive force. That's roughly equivalent to 270 pickup trucks all pulling in perfect unison. Meanwhile, across the Atlantic, the London and Northeastern Railway faced a different crisis entirely. They needed to prove that steam could compete with emerging diesel technology on high-speed passenger routes. Their answer was Flying Scotsman, a sleek 462 Pacific that became the first steam locomotive officially authenticated at 100 miles per hour during a 1934 test run. But here's what's remarkable. It wasn't built just for that one record. It was designed to haul express passenger trains nonstop from London to Edinburgh, 392 miles in just over 8 hours. Up in Minnesota's Iron Range, the Duluth-Mesabe and Iron Range Railroad had perhaps the most brutal job of all, moving America's iron ore from remote mines to Great Lakes shipping ports. Their solution was the Yellowstone, a 2884 design that could actually outpull both the Big Boy and Flying Scotsman. At 140,000 pounds of tractive effort, these locomotives routinely dragged 180-car ore trains across the Minnesota wilderness. Three legendary machines, three completely different missions, and therein lies our problem. The numbers don't lie, but they don't tell the whole truth. Let's talk about what these numbers actually mean, because raw statistics can be deceiving. The Big Boy's 135,375 pounds of tractive effort sounds impressive until you realize the Yellowstone topped it at 140,000 pounds. But tractive effort only tells you how hard a locomotive can pull when starting from a dead stop. It doesn't account for speed, efficiency, or sustained power output. Here's where it gets interesting. When Union Pacific tested Big Boy number 4014 against their latest diesel locomotives in 1943, the steam giant produced roughly 6,000 horsepower and held its own against multiple diesel units. The test was so convincing that UP decided to stick with steam for the duration of World War II. Flying Scotsman's 100 miles per hour achievement might seem quaint compared to today's high-speed rail, but consider the engineering challenge. This was 1934, the same year the first streamlined passenger car rolled off an assembly line. Flying Scotsman was pulling heavy steel carriages on track designed for much slower speeds, using technology that hadn't fundamentally changed since the 1800s. But here's what the speed record doesn't capture. Flying Scotsman's real innovation was endurance. In 1928, it inaugurated the first non-stop London to Edinburgh service, equipped with a corridor tender that allowed crew changes while moving at 60 miles per hour. The locomotive scooped water from track troughs 6 times during the 392-mile journey, never stopping for fuel or crew relief. That's not just speed, that's sustained precision over nearly 400 miles. The Yellowstone story is perhaps the most remarkable because it's the least known. These locomotives had the highest adhesive weight of any steam engine ever built, 560,000 pounds pressing down on their driving wheels. That crushing grip meant they could start trains that would make other locomotives spin their wheels helplessly. In 1943, when some Yellowstones were leased to the Denver and Rio Grande Western to help with mountain freight, Rio Grande's chief of motive power called them the finest engines ever to operate on that line. So which number matters most? Depends entirely on what problem you're trying to solve. Built for purpose, not records. The genius of these locomotives wasn't in their absolute capabilities. It was in how perfectly they matched their intended missions. Union Pacific's big boys were designed for one specific stretch of track, the hellish grade between Ogden, Utah, and Cheyenne, Wyoming. Before the big boys arrived, UP trains required helper locomotives, sometimes 2 or 3 additional engines, just to make it over the Wasatch Range. Each helper district required extra crews, more fuel, and complex coordination. The big boy eliminated all of that. One engine, one crew, 3,600 tons, up a 1.14% grade. The first test run in 1941 proved the concept. Big Boy number 4000 hauled a 3,500-ton train up the grade solo, immediately demonstrating its value. But here's what's fascinating. Big boys were actually over-engineered. They were capable of 80 miles per hour running, even though freight service rarely required speeds above 45 miles per hour. This wasn't waste. It was deliberate. By building in that speed margin, Union Pacific ensured the locomotives operated well within their stress limits during normal service, reducing wear and extending service life. Flying Scotsman faced an entirely different challenge. The London-Edinburgh route was a prestige run, LNER's flagship service competing directly with rival railways. Speed mattered, but so did reliability and passenger comfort. The locomotive's 3-cylinder design provided smooth power delivery, while its corridor tender innovation allowed 8-hour non-stop runs that would have been impossible with traditional crew change requirements. The genius wasn't just in the 100 miles per hour capability, it was in the system integration. Flying Scotsman had to coordinate with trackside water troughs, maintain precise timing for crew changes, and deliver passengers on schedule day after day. In 1989, decades after retirement, it proved that reliability by setting a world record for the longest non-stop steam run, 422 miles across Australia without stopping. The Yellowstones were perhaps the most specialized of all. Built specifically for Minnesota's Iron Range, they were optimized for one job: moving maximum tonnage at modest speeds over relatively short distances. Their 63-inch driving wheels were smaller than the big boys' 68-inch wheels, prioritizing pulling power over speed. The massive firebox could burn bituminous coal efficiently, while all-axle roller bearings reduced friction under crushing loads. During World War II, when iron ore demand peaked, these locomotives became the backbone of America's steel supply chain. Every battleship, tank, and aircraft built with Midwest steel depended on ore that a Yellowstone had likely pulled from Minnesota mines. The crown goes to... So after examining the evidence, which locomotive deserves the crown as the greatest ever built? The answer depends entirely on how you define greatest. If you measure by raw spectacle and balanced capability, the big boy wins. It was the largest steam locomotive ever built, capable of impressive speed despite its size, and perfectly matched to its intended mission. The fact that Union Pacific spent millions restoring Big Boy number 4014 to operation in 2019 purely for public relations and heritage tourism speaks to its enduring appeal. If you value innovation and cultural impact, Flying Scotsman takes the crown. It was the first steam locomotive to circumnavigate the globe, touring North America in the 1970s and Australia in the 1980s. Its 100 miles per hour achievement proved steam's viability in the diesel age, while its corridor tender and water scooping capabilities showed that steam could adapt to emerging operational demands. If you respect pure engineering optimization, the Yellowstone deserves recognition. These locomotives were so perfectly designed for their mission that none required major rebuilds during their 20-year service lives. They were delivered with cutting-edge technology and remained state-of-the-art until retirement. But here's what I find most remarkable. Each of these locomotives succeeded not because they were the biggest, fastest, or most powerful in absolute terms, but because they solved their specific problems better than any alternative. The Big Boy didn't need to be the most powerful locomotive ever. It just needed to replace 3 helper engines on the Wasatch grade. Flying Scotsman didn't need to be faster than Mallard's. It needed to maintain 60 miles per hour for nearly 400 miles while scooping water and changing crews. The Yellowstone didn't need versatility. It needed to move iron ore more efficiently than any other machine on Earth. In the end, the greatest train ever built might not be the one with the most impressive statistics. It might be the one that most perfectly understood its purpose and executed it flawlessly, day after day, for decades. That's a lesson that extends far beyond locomotives. Sometimes the most profound innovations don't come from pushing every limit simultaneously. They come from understanding exactly what problem you're solving, then engineering a solution so precise it seems inevitable in retrospect. When you see these machines today, Big Boy gleaming in restoration, Flying Scotsman drawing crowds on heritage railways, or Yellowstones preserved in Minnesota museums, you're not just looking at impressive technology. You're seeing the physical embodiment of human problem solving at its most elegant. 3 different problems, 3 perfect solutions, each earning its place among the greatest achievements of the industrial age. The crown doesn't belong to just one of them. It belongs to the idea they represent, that true engineering excellence comes not from building the biggest or fastest machine possible, but from building exactly the right machine for the job at hand.